All right, so we're going to do some practice problems today for, why did I do that? We're going to do some practice problems today for molarity. Calculate the molarity of the solution produced by dissolving 30 grams of sodium chloride in enough water to form 625 milliliters of solution. Okay, so let's digest this question together. It says calculate the molarity. So I know I'm looking for molarity, which is moles over liters. It's produced by dissolving 30 grams of sodium chloride. Enough water to form a 625 milliliter solution. All right. So we know that we're going to put this many grams of sodium chloride into this much solution. So this is one of those ones where we're going to think, all right, in the real world, I'm taking this salt and I'm putting it in this much solution. So my concentration is 30.0 grams in 625 milliliters. Okay, but I want molarity. So I need to change my grams to moles. Right? And so what that means is I need to calculate a molar mass for that. So I'm going to pull out my periodic table and I'm going to calculate molar mass like we've done a ton of times. I look at sodium chloride, I see 1 atom of, or 1 mole, 1 atom of sodium. I see just 1 chlorine. Come back to my periodic table. Sodium has a mass of 23.0. Chlorine has a mass of 35.5. So we can just add those together. So 58.5 grams per mole. And that's what would go in our problem for our conversion. Okay, so looking at this and I say, all right, well, grams is going to cancel. I have moles on the top, which that's what I'm looking for. But when I look at my problem, I still have milliliters on the bottom. What do I want on the bottom? Liters. So we're going to convert those milliliters to liters. Make sure milliliters are on the bottom, so we need to put the milliliters on the top in our conversion in order for them to cancel. We know that 1 liter is 1,000 milliliters. Okay. And so then my milliliters cancel. And let's see what we got. 30 times 1 times 1,000 is 30,000. And across the top, the only unit I have is moles. Across the bottom, well, I can't do that math in my head. So we will pull up our calculator and say 625 times 58.5. We'll do times 1 for clarity. We're going to have 36,562.5. We go across the bottom. Our milliliters canceled, our grams canceled, but we have liters. So now we can see that our units match molarity. We have molarity. And we need to do our last part of the problem. Okay. So here is our answer. We look at our problem. We're given 3 significant digits. So our answer equals 0.82. The 5 tells the 0 to go up. Molar. So this right here would be the molarity of our solution. Give me a thumbs up if that problem made sense and you're like, yep, I can do that. Okay, good. I'm going to go ahead and do 2 and 3 because they're just a little different. And then you're going to do 4, 5, and 6. Okay, they mimic these problems. So let's scroll down to 2. Oh, wait, I'll leave that on the screen for a second. I'll scroll down to 2. All right, how many milliliters of solution would it take to form 2.50 molar solution from 35 grams of calcium iodide? Well, all right, so let's kind of digest the problem. We are asked for milliliters. We have, says it wants to form a 2.50 molar solution. So what does that number mean? 2.50, if we go back to molarity, that's 2.50 moles per 1 liter. So we are probably going to use this as a conversion at some point. And then we have 35 grams of calcium iodide. Okay, so we're going to start with the number that is not a conversion. We're going to start with what we've been given in our problem. Okay. And we have grams. We know that we need to get to moles somehow. So let's go ahead and set up our problem. We're going to start with what we have. And I know I have to get rid of grams. What's going to go on the top of this conversion? Let's look back. Moles. Because when I needed to get rid of grams here, I came up with moles. So we're going to have to find that molar mass. Let's go ahead and calculate that like we did earlier. We have calcium, we have iodine, we have 1 calcium, we have 2 iodines. We're going to go back to our periodic table. I'm going to say calcium has a mass of 40.1. Iodine has a mass of 126.9. And you guys know I can't do that math in my head, so we'll pull our calculator back. 253.8. Okay, so this number is grams per mole. That is our molar mass. Okay. All right, so that's our first step. Take care of our grams. Now we have moles. If I want to come up with milliliters somehow, I need to cancel out moles. That's where this molarity is going to come into play. So we're going to use our molarity that we want to come up with as a conversion in this step. Okay. So you have to remember that molarity can be used like this. Otherwise, your problems aren't going to work out. So now we have moles. Moles are going to cancel. We have liters. What is our question asking us for? Milliliters. Okay. So we need to just convert liters to milliliters. 1,000 milliliters. So our liters canceled. All of our units have canceled except for milliliters, and that's what the question asked us for. So now we can just go across and do the math that it's asking us for. So, well, 35 times 1 times 1 is still 35, times 1,000 is 35,000. And our unit on the top is milliliters. And then we'll bring in our calculator for this one. 293.9 times 2.50 times 1 is 734.75. And we look across, all of our units on the bottom have canceled. So 35,000 divided by 734.75 equals, okay, there's our answer. In our problem, we were given 3 significant digits. So our answer, of course, has to have that. 47.6, and the 3 tells the 6 to stay the same. 6 milliliters. Okay. So here's our answer for number 2. What is the hardest part about a question like this? I'm just like, what do you think? Okay, so knowing when to round it to. Okay, we got to remember those significant figures rules. That's from a long time ago. So give me a thumbs up if you feel totally comfortable with the factor label unit analysis part. So we got some sideways. We got some, okay. All right. It's never going to leave us. So we got to kind of remember, follow our units. Make sure that whatever we end up with that's not canceled out is what our question was asking us for. All right, we'll do 3, and then I'll give you time to work, and I want to see if you guys can do it, like on your own. So here's 3. Whew. What is the mass of magnesium carbonate needed to produce 1,500 milliliters of a 0.500 molar solution? All right, so now this one, it's asking us what is the mass. So I am looking for grams, because we measure mass in grams, of magnesium carbonate. Okay. So we know at some point we're going to have the molar mass of this, because we know that that molarity is moles per liter. Okay. We're producing 1,500 milliliters. So this is probably the number that we're going to start with, because we know that our molarity is really 0.5 moles per 1 liter. So that this molarity of the solution we have to get in our head is our conversion that we're using. Okay. All right. So let's start with what we know, our solid number. 1,500 milliliters. What's the first conversion that we have to make? What unit do we have to use to get to? Liters, right. So we have to convert milliliters to liters. So milliliters on the top, milliliters on the bottom. 1 liter is 1,000 milliliters. Okay, now we have liters. What can we use to get rid of liters? Our molarity. That molarity that's given to us in our problem is what we're going to use to get rid of liters. Okay, so our liters cancel. And this kind of problem, we sort of do this a little bit backwards from what we're used to. We're used to going from grams to moles. But now we're going to go from moles to grams, because we want to cancel moles to come up with grams, which is what we're asked for in our problem. So we know 1 mole of the magnesium carbonate, but we need a mass. So let's go ahead and calculate that molar mass. So we look at magnesium carbonate, we see magnesium, we see carbon, we see oxygen. 1 magnesium, 1 carbon, 3 oxygens. We've already memorized oxygen. We've already memorized carbon. Magnesium, I don't know if you've memorized or not, but it's 24.3. So 3 times 16 is 48. So I'm going to add this up on the calculator just so we don't make a silly mistake. Grams per mole. So this is a good example of how you just have to follow your units to know where your number is going to go. Okay. So milliliters canceled, liters canceled, moles canceled. And we're left with grams of magnesium carbonate, which is what we're asked for. So now we can go ahead and we're going to multiply straight across. So let's get that in there. 1,500 times, we don't need to do times 1, but times 1 times 0.500 times 84.3 equals, okay, this is our number on the top. And we look at our units as grams. Okay. Then we go across the bottom, and the only thing we have is 1,000. So 1,000 times 1 times 1. We take our number. Just gonna, you can probably do that in your head, but we're gonna do it on the calculator just to be sure. 63.225. Now, notice we had 2 significant digits and we had 3 significant digits. We should really stick with the smallest number of significant digits because we're multiplying and dividing here. So that would be 63. The 2 tells the 3 to stay the same. So 63 grams magnesium carbonate. Okay. Give me a thumbs up if that made sense. Okay. All right. Your job is to do number 4, which is just like number 1. You're going to do number 5, which is just like number 2. And you're going to do number 6, which is just like number 3. Calculate the grams. So go ahead and finish those 3, and then you have time to work on the CK12 material.